All right, we are going to be looking at square root functions and inequalities with them. So just a little twist to what we were doing. This time I'm not going to give you the graphs. You're going to need to create the graphs and give me the domain and the range. So hopefully this will go okay. You're going to use your calculators to help you do this. So hopefully you've got your graphing calculator here and you can kind of help practice with me. But the easiest thing to do is to be able to graph a square root function and have your calculator help you. So what you're going to do is you're going to put the square root function into your y equals key. So of course press y equals, I'm already there. This one happens to be the square root of 2x minus 6. So the square root of 2x minus 6 and hit graph. And of course if you're having stat plots or something turned on, hit second y equals number 4, enter. And if your screen does not match mine because your window is different, hit zoom 6. And those should be some troubleshooting errors that will help you. But here is what the square root of 2x minus 6 looks like. The first thing you want to do is kind of have a starting point. It looks like 3, 0 is my starting point, but I really and truly can't be sure. I'm going to hope that my table can help me at least a little bit. So I am going to go to my table here, and I want you to notice that 3, 0 is a point. I also want you to be careful though, because your table only shows you integer values for x, and sometimes your integer values, you need decimal values and not just integer values in your tables in order to get your starting point. Okay, I do want you to notice that anything below 3 gives you an error. And if you look back at the graph, that kind of makes sense because there is no piece of that square root function that is showing below negative 3, or at least what looks like negative 3. Also, if you think about it algebraically, you're taking the square root of a number, okay? And when you take the square root of a number, you can't take the square root of a negative, or you get imaginary solutions which don't show up on graphs. And so we'll talk about how you get that algebraically in a minute, but remember that you can't take the square root of a negative number, okay? So back to our function here. Remember I said you can't take the square root of a negative number. So to get your starting point, you actually have to really think about this algebraically, and you are going to look at this, what's underneath the square root symbol right here, okay? And that's 2x minus 6. The smallest that quantity can be is 0, because the smallest number you can take the square root of is 0. So you're going to set that equal to 0, and you'll solve. So of course you'll get 2x equals 6, and then x equals 3. So indeed your starting point is 3, 0, but you need to verify that algebraically instead of just trusting your table, because again your table only shows you integer values, and sometimes you need fractional or decimal values which won't show up on your table. Okay, so you always have to verify that algebraically. So now I am going to plot my starting point over here at 3, 0. And now I need some other points to plot. And the easiest way to do that is to go to your table and kind of get a few points to plot. And you might need to estimate a little bit here. And so I am going to go down on my table here, maybe. It's not letting me go down, is it? Let's see. All right, let's go back to my table and see if it lets me do it this time. There we go. If I go down on my table here, I'm just going to get a few more points to plot. So like 5, 2 is probably a good one to plot. I can do that, no problem. So I'm going to plot the point 5, 2. And then I'm going to go down and I'm going to get just another one that I can estimate. Like 9 and 3.46 is really close to 3.5. So I'm going to grab 5, 2 and 9 and 3.5. And I'm going to just plot a couple points on my graph and go from there. So 5, 2 would be right here. And 9 and 3.5 would be right about there. And of course I'm estimating. Okay, now before you connect the dots, you want to pay attention to whether you should connect them with a solid line or a dotted line. Remember that when this inequality symbol is not underlined, no matter which direction it goes, if it's not underlined, you need to connect those with a dotted or a dashed line. Okay, so my square root function is going to look like that. It's dashed. Okay, now you need to think about shading because you're not done here. And your shading, this is a less than symbol. So you want to shade every place that is less than that square root symbol. And I hope you can picture that that is underneath it. You need to sort of draw yourself this imaginary line that goes down here, because you can never have x values that are less than 3, or that will give you a negative underneath your square root, which can't happen. Okay, so think about extending that line where your starting point is and just making a vertical line at that spot. And then this is a less than symbol, so you want to shade underneath. So I need to shade everywhere here, being very conscious that I never cross that x equals 3 or that vertical line right there. Okay? So now, if you look at your domain, again, your domain is your x values. So I'm going to think about dragging this line right here from the left to the right. I'm not hitting any shaded part, not hitting it, not hitting it, not hitting it, not hitting it. I do start hitting it here at exactly 3, and it can be exactly 3, actually. If I plug in 3, I get 0, so I really probably should make this part right here solid, because it can be exactly 3. It doesn't really matter, but it can be exactly 3. And then, of course, I'm going to hit that shading anywhere to the right of that. So my domain will go from 3 up to positive infinity if I write it in interval notation. If I write it in set notation, it will be all the places that are bigger than or equal to 3. So that's my domain. And then, of course, oops, my range. When I do my range, I am going to use the green line here, and I'm going to start at the bottom and move up. So remember that these lines continue to earn the shading, and the black line and the red and the green too. They all go on forever and ever. So I'd actually be intersecting some shading down here, even though it doesn't look like it, because you need to remember that you'll extend both the shading and the black line. So I'm hitting shading from negative infinity, and I'm hitting shading, I'm hitting shading, I'm hitting shading, I'm hitting shading, hitting shading, hitting shading. Even up here, because my square root function is going to continue to go like this, even up there is, because it's getting wider and taller as it moves to the right, the green line and the square root function are eventually going to intersect. So my range actually goes from negative infinity up to positive infinity. And when you write that in set notation, it'll look like this. The set of all y's such that y is any number. Y is any real number. And here's how you write that. Y is an element in the real numbers. Y is a part of or belongs to all real numbers. Okay? All right, and the next one, again, we're going to use our calculators to help us. So we have 3x plus 5, the square root of 3x plus 5. So I will go up to my y equals, and I will put in the square root of 3x plus 5 and graph it. Okay, so it looks like my starting point might be negative 2, 0. It's really kind of hard to tell from my graph, but that's what it looks like. I'm going to go to my table and see if I can get anything from my table. Well, negative 2, 0 must not be the starting point, and negative 1 is not the starting point either. It doesn't look like. Here's a situation where I'm telling you that your table, in order to get your starting point, is not the full proof method. You really have to look to get your starting point at the equation and get it algebraically, okay? And again, to do that, you're going to take what's underneath the square root and you will set it equal to 0, and that's because the smallest number that you can take the square root of is 0. You can't take the square root of negative numbers. So of course 3x equals negative 5, and x would be negative 5/3. Okay? So that's your starting point. Your starting point is negative 5/3, which of course you're going to have to estimate a little bit. That's negative 1 2/3. So negative 1 2/3 will be right about there. I'm sort of estimating this, but that's how that will go. Okay, and then you're going to go to your table and you're going to get a few more points to plot. And you're going to have to estimate these because they aren't always going to come out pretty. Okay, so I'm going to get a few more points to plot. Let's do 1 and 2.8, and let's do 5 and 4.5. I'm going to just kind of plot these before I forget. So 1 and 2.8, 1 and almost 3, and 5 and 4.5. So that'll be about right there. And let's put 1 kind of towards the end just so that we can estimate this. Let's get 1 at 10. Let's see what 10 is. 10, 9 or 10. 10 is almost 6, so 10 and 6 are close enough. Okay, 10 and 6. Will be right about there. Okay, so now I can sort of sketch the square root function. Again, it is a little greater than symbol, and so I need to think about that in terms of whether it's solid or dotted, and it's not underlined, so it will be a dashed line that I want to connect those dots with. Okay, and then of course you're going to think of this imaginary line sort of right here that extends. This is and it could extend this way too, and it doesn't really matter, but you can never cross that line no matter which direction you shade. Okay, you cannot cross that line of -5/3. This is a greater than problem, so you want to shade all of the spots that are greater than that square root function. So you would actually shade this direction, okay? And that's where you would shade because that's the places that are bigger than that square root function. All right, so your domain, I hope you can see, you start the shading at -5/3 and you end it at positive infinity. And so then in set notation, it'll look like this. And your range goes from 0, oops, sorry, exactly 0, to positive infinity. And then, of course, y such that y is greater than or equal to 0. All right, so that's how that goes. And one more, and we are done. Okay? I don't know why this kind of came out funny, but it did. So this should say y is less than or equal to, I don't know if you can kind of tell that up here, negative square root of x plus 3 minus 2. So again, you're going to put that into your calculators and go from there. Okay, so here we go. I'm going to clear this out. I have negative square root of x plus 3. Close that. And then minus 2. So here is what that looks like. It looks like the starting point right here would be at -3, -2, which it very well could be. Okay. When you think about doing that, you want to look at your table. And let's go up to -3 and see what happens. At -3, I do have -2. And then notice anything underneath -3, it's giving me an error, but remember, be caution of the fact that there might be some decimals or fractions in there that are not appearing on your table. So again, you have to prove this algebraically, and you want to take what's inside that square root symbol and set it equal to 0, because that's the smallest number you can take the square root of. So x plus 3 equals 0, of course I'm going to get x equals -3. And when I plug -3 in, then I have the square root of -3 plus 3 minus 2. Well, this quantity is 0, and so 0 minus 2 gives you -2. So when I plug the point -3 in, I get -2 for my answer. And so indeed that is my starting point, -3, -2. And so I'm going to go ahead and plot that. Okay, and then of course again your tables are very, very helpful. And so I'm going to plug a few of these in. So let's do -2 and -3, and 1 and -4 are good ones to start with. -3 and -2, and 1 and -4. Let's see, I already did that. Oh my gosh, I'm forgetting what I'm doing already. Let's see, it was -2 and -3, and 1 and -4. And let's get a couple more. Let's go down, let's get one down towards the end here. 1 and -4, let's get one that's like at 10. Let's see, at 10, whoa, got a little snap happy there. At 10, it is -5.6. So let's just plot that just so that we have a dot to connect. So at 10, it's at -5.6. So that would be right about there. Okay. This inequality symbol is underlined, so you are going to connect it with a solid line this time. And again, you want to think of making sort of that imaginary line right here that it cannot ever, ever, ever cross. Okay, cannot cross there. And then when you shade this, you want all the spots that are less than that square root symbol. So you are going to shade down here when you shade this, okay? So our domains, we start hitting it, hitting the shading at exactly -3. And really, I should make this be a solid line because it can be exactly -3. So I will hit this from -3 up to positive infinity. Or if I do it in set notation, it would look like this. And then your range, of course, you're hitting shading all the way from the bottom all the way to the bottom. You're going to hit at least some shading. So from -infinity up until I hit the point right here at -2. That's the highest point I can get to where I would intersect with some shading. So I'm going to go from -2 all the way up to, or from -infinity all the way up to +2. Okay, and then the other way around, I will go set of all y's such that y is less than or equal to, and not +2, -2, sorry. Less than or equal to -2. All right.